So the fact that we have solar eclipses is kind of just a coincidence. The diameter of the sun is about 400 times greater than the diameter of the moon, but at the same time, the distance between the sun and the earth is about 400 times greater than the distance between the moon and the earth, meaning that viewed from Earth, the sun and the moon appear to be the same size. Sometimes. I mean, the distance between the earth and the sun varies, and the distance between the earth and the moon varies, but sometimes they're the same size. If the moon was any smaller or further away from Earth, then it's possible the moon wouldn't be able to completely cover the sun. In fact, the moon is actually progressively getting further and further away from Earth at a rate of about 1.5 inches per year. Also, the sun is going to get more luminous over time, and so might appear larger in the sky. Sometime in the future, perhaps in as little as 600 million years, the moon will be far enough away from the Earth that the Earth will no longer get total solar eclipses, and we will only have partial or annular eclipses. But for now, we do get total solar eclipses. As a matter of fact, last month there was a solar eclipse, which from some parts of the United States, Canada, and Mexico could be seen as a total solar eclipse. In fact, it's going to be the only solar eclipse in the 21st century to have appeared in all of those countries. Where I live in Minnesota, we could see a partial eclipse, or we would have if it hadn't been completely overcast and cloudy. I was trying to at least tell if it was like darker than usual, but there was literally no way to tell that there was an eclipse going on. But yay, I'm glad everybody else had fun. It's surprising how much of the sun needs to be covered in order there to be any noticeable difference in the amount of light. In order for there to be any noticeable difference, there needs to be at least 90% coverage of the sun. And even at 99% coverage, it would still only be as dark as civil twilight, which is not that dark. One thing that is interesting is that solar eclipses aren't actually that rare. For example, the next solar eclipse will be later this year on October 2nd, 2024. But it won't be a total solar eclipse. It'll be an annular eclipse, and it'll only be visible from southern Chile and Argentina. We can kind of see what is rare about solar eclipses. It's rare for there to be a total solar eclipse if you are only looking at a specific static location. But if you look at the entire globe, as well as solar eclipses that aren't just total solar eclipses are actually surprisingly common. In fact, there are between 2 and 5 solar eclipses that can happen every year, up to 2 of which can be total, although normally there's a total solar eclipse about once every 18 months on average. But it can happen where there are 2 solar eclipses in 1 year. The next total solar eclipse will be on August 12th, 2026, and be visible from Greenland, Iceland, Spain, and northeastern Portugal. The next total solar eclipse to be visible from the United States, from the continuous United States, I should say, will occur on August 23rd, 2044, and be visible from eastern Montana, western North Dakota, and this is confusing, northwest South Dakota. Right. The next total solar eclipse visible from the United States that won't be visible in places that aren't just in the middle of nowhere will occur on August 12th, 2045. I've kind of been throwing around the terminology for the different types of solar eclipses without explaining them, so I'll do that now. A partial solar eclipse is when the moon partially blocks the sun, but it's not perfectly aligned with Earth's, and the moon only partially obstructs the sun, creating a sort of crescent moon shape with the sun. A crescent moon shape? You know what I mean. Exclusively partial solar eclipses happen in about 35% of eclipses. An annular solar eclipse is when the moon is at or near its apogee, its furthest possible distance from Earth, and so the moon can't completely cover the sun, and so an annular eclipse can occur, where the moon is completely entailed within the area of the sun, but it doesn't appear large enough to actually cover the sun. This causes the sun to form sort of a ring shape. Annular solar eclipses account for about 33% of eclipses. And this is a side note. Similar to how the moon will in the future be far enough away from the Earth that Earth won't have any more total solar eclipses, in the past, the moon was actually closer to Earth, so much so that we used to never have annular solar eclipses. Then we move on to total solar eclipses, which is where the moon completely blocks the sun in what is known as a totality. This happens in about 27% of all eclipses. However, total solar eclipses aren't the rarest type of solar eclipse. The rarest type is a hybrid solar eclipse, an eclipse that is visible as an annular from some locations, but visible as a total solar eclipse from other locations. And these hybrid solar eclipses happen in less than 5% of all eclipses. So there are some pretty interesting phenomena that can happen during a total solar eclipse, and we'll go over a few of them. Bailey's beads occur because the moon isn't perfectly spherical. There are valleys and craters and mountains and all sorts of geologically interesting features. So when the moon almost completely covers the sun, the light from the sun only passes through some parts of the moon through craters and things like that, while other parts of the moon, like mountains and hills, obstruct the light from shining through. So you can kind of see these sort of beads of light. And just before totality, if there are just one or two beads available, there can be this thing called the diamond ring effect, where the bead sort of shines like a diamond. I mean, okay. During totality is the only time you can see the corona, which is the outermost part of the atmosphere of the sun, which is normally invisible because of the rest of the sun. The photosphere is so much brighter than the corona. There are these things called shadow bands that can happen immediately before and after totality on plain colored surfaces. It's possible to see these undulating, alternating lines of light in dark called shadow bands. It's kind of like the shadows that appear at the bottom of a swimming pool. I don't know why that happens, but maybe someone knows, probably. The weather can actually be pretty dramatically affected by solar eclipses. The temperature can drop 5 to 10 degrees Fahrenheit during an eclipse. Sometimes if there's wind during an eclipse, it will stop during the eclipse and resume after, but may blow in a different direction. So animals can behave quite strangely during eclipses. A drop in temperature will cause a drop in atmospheric pressure, which could cause animals to think that a storm is coming. Animals could also be confused and think that it's night. So maybe crepuscular animals, that is animals that are active during dawn and dusk, might become active. So the crickets might start chirping. And after totality, animals like birds might sing, thinking that it's morning. During totality, you might see this 360-degree sunset where there appears to be a sunset on the horizon in every direction you look. I don't know why that happens. Some weird physics thing. And the final thing is that it could be actually dark enough during totality that you could actually observe other stars in the sky, which brings us to our next interesting fact, which is that in 1919, a total solar eclipse helped provide evidence for Einstein's theory of general relativity. General relativity predicts that gravity can change the trajectory of light. So in an experiment carried out by astronomers named Frank Dyson and Arthur Eddington, called the Eddington experiment, two teams went to observe a total solar eclipse on May 29th, 1919. And the eclipse blocked out just enough light from the sun that other stars were detectable in the sky. The idea was to measure stars that appeared close to the sun when looking from Earth and compare their positions during the eclipse to where they would have been had the sun not been there, because we would expect the mass of the sun to actually shift the light from these stars a certain amount given the predictions of general relativity. I mean, the shifting is not that much, mind you. Einstein would have predicted a shift of only about 1.8 arc seconds for some of these stars, an arc second being 1/360,000th of a degree, which I mean, I don't know how much a degree is, but I don't think it's that much. The observations were taken in Brazil and on the island of Principe, and they were the first to offer conclusive results and had results in line with Einstein's general relativity as opposed to Newtonian physics. It wasn't the first experiment like this attempted, however. There were experiments in the past that were inconclusive because of bad weather, faulty equipment. I think one experiment was interrupted by the outbreak of World War I, which is unlucky. Eclipses can be useful for historians because solar eclipses that have been recorded by people in the past can be dated precisely today by historians, right? Because we can calculate the date of solar eclipses into the far past. According to the historian Herodotus, a solar eclipse interrupted a battle between the Medes and the Lydians, which is modern-day Iran and Turkey. Thinking that the solar eclipse was a bad omen, they stopped fighting and declared a truce. This could be the earliest event, which we have a precise date for, May 28th, 585 BC. Although it's not certain that this is the date that this happened, but it's one that's often suggested. Also, according to Herodotus, this also might have been the first time a solar eclipse was predicted ahead of time by the Greek philosopher Thales of Miletus. I was trying to look up what city is the most likely to experience total solar eclipses. And I found one study from timeanddate.com. So first, a few interesting statistics. A random city will have a total solar eclipse every 374 years on average, an annular eclipse every 226 years, and a partial eclipse every 2.6 years. Solar eclipses are most likely to occur in the Arctic and Antarctic circles. Total eclipses are also more likely to occur in the northern hemisphere because summer in the northern hemisphere is when the Earth is near its aphelion, its furthest distance away from the sun, and so the apparent size of the sun is smaller during the summer months when the sun is out for a longer time, and so there's a better chance that a total solar eclipse can occur. So perhaps the city that's most likely to experience a total solar eclipse is the city Longyearbyen in Svalbard, Norway, the northernmost settlement on Earth. Sure, let's go with that. Just one last quick thing. I did want to share with you a couple of interesting words that I found. If you are witnessing a total solar eclipse, you are in the part of the moon's shadow called the umbra. If you are witnessing a partial solar eclipse, you are in the penumbra. And if you are witnessing an annular solar eclipse, you are witnessing the antumbra. Also related, someone who loves solar eclipses and travels around the world to see solar eclipses is known as an umbraphile. Yeah, some people have seen like dozens and dozens of solar eclipses in their life, which is crazy. I'm excited because in the future, there'll be a total solar eclipse in Minnesota where I live. And it'll happen on September 14th, 2099. I mean, it'll be nice when I'm 98 years old to be able to wheel out of the nursing home, look up at the sky, and to be able to say that beyond that dense cloud cover, there's a total solar eclipse happening.